Hi, in this video I'm going to go through a tricky question on electrochemical cells. So the question is in the information below, so you can click on the link and give the question a go yourself before going through it here. So it gives you, first of all, some standard electropotentials. So we've got here silver, an electron going to silver, silver ion going to silver, chlorine going to chloride minus ion, copper 2 plus going to copper, Fe3 plus going to Fe2 plus, and iodine going to the I minus ion. And then it gives you its electropotential data. Now, they're not in order, is the first thing to see here. Often you'll see these in order with the most positive at the top, most negative at the bottom, but this time they're not. So we've got to pick out and have a look and analyse each individual data. So the first question asks you to define the term standard electropotential. So this is the value we get when we compare it against the hydrogen, any half equation against the hydrogen. So this is going to be the potential difference, or EMF, of a half cell connected to a standard hydrogen half cell under standard conditions. And those standard conditions are 298 Kelvin, 1 mole per decimeter cubed of the solutions, and 1 atmosphere, or 100 kilopascals. So 3 marks here, one for saying the potential difference, or EMF, of a half cell, connected to a standard, 1 mark connected to a standard hydrogen half cell under standard conditions, and then 1 mark for getting all the standard conditions in there as well, for the 3 marks on that. Next up, it asks us to look at a diagram. It says the diagram below shows an incomplete cell consisting of copper 2 plus and copper and Ag and Ag plus. So we've got our half cells, and it just wants us to complete the labelling on each of these here. So it's already given us copper solid, and it's given us silver positive ions in solution. So it's aqueous, copper solid. So now what we need to add in, and I'll do this in a different colour so we can see the bits we add in, we need to add in that this is the copper 2 plus solution. We know it's going to be in solution, so we create our half cell, and we know it's copper 2 plus because in the question it tells us up there that it's copper / copper 2 plus. On this side we've got our silver in solution, so now we need our silver, and that needs to be solid. Then linking them up, we're going to have a wire with on it a voltmeter, so we're going to see the potential difference. And we also need a salt bridge. I think I've got everything there then for the 2 marks. And it says on the diagram, show the direction of the electron flow in the circuit if a current was allowed. I'm just going to do that at the bottom, so I'm going to move this to here. So make sure you got the state symbols on all of these. If we look at copper, it goes copper 2 plus 2e minus goes to copper. We've got here then copper 2 plus 2e minus goes to copper, and silver is Ag plus plus E minus goes to silver. And the values are the most important part of this. We've got 0.34 for copper and plus 0.80 for silver. So copper is more negative. So copper is going to go this way. It's going to be a reducing agent. It's going to become oxidized, which means silver is going to go that way. So it's going to gain electrons and go into our silver. So we spotted this because copper is the more negative value. If they were doing these arranging this generally, they arrange the table in order as well. So copper would be the top. Then it looks like iodine. Then our iron 3 plus. Then what's next? Silver, and then the chlorine. So if it's going that way, this must go then. Copper is producing electrons essentially, donating electrons, and silver's taking them in. So they're going from copper and they're going to the silver. So from the copper to the silver. Part 3, calculate the standard cell potential, which is do 0.80 minus 0.34 to give us 0.46 volts for that 1 mark. And the overall cell reaction, I don't really have space for this, so I'll just rub this out to create myself some space. Leave those in a bit. I'll need 2Ag plus 2E minus going to 2Ag because I've got 2 electrons for each copper, but just 1 for the silver. And I've already said it's going from copper plus 2Ag plus will go to copper plus 2Ag plus will go to copper 2 plus 2Ag. Yeah, that looks right. Electrons then cancel out and we're all good. Finally, chlorine will oxidize Fe2 plus to Fe3 plus, but iodine will not. Explain why using the electrode potential data. So I'll have to draw each of those out and we'll have a look at those. So chlorine is half Cl2 plus E minus into Cl minus and plus 1.36. Iodine is half I2 plus E minus goes to I minus, and that's plus 0.54. So we can guess that iron's going to be somewhere in between these. Fe3 plus E minus goes to Fe2 plus, and that's plus 0.77. So it is in between. So if we have a look at this, and we first of all look at chlorine and iron, and we go, well, which one of these two is the most negative? And out of that, iron's the most negative. So if we took chlorine and iron's going to go from right to left, and chlorine will go from left to right. So that will take Fe2 plus to Fe3 plus, and chlorine to the chloride. However, so that would work because iron 2 plus, the iron half equation is more negative than the chlorine half equation. And then iodine is more negative than that iron. So if we were doing that iodine reaction, iodine will go from right to left, and iron in that case would go from left to right, so we'd reduce the Fe3 plus to Fe2 plus. So chlorine will, because iron's more negative. Iodine won't, because iodine's more negative than the iron. And that was that question.